Hey everyone, I'm Umair, an AI engineer and educator, and in today's video, we're going to build something super cool, a fully functional AI-powered retail support chatbot. We'll start from scratch with a basic terminal-based agent, and step by step, we'll make it smarter, adding memory so it remembers past conversations, connecting it to real inventory, and support data using retrieval tools, and finally wrapping it in a clean web interface using Streamlit and FAST API. This project is a complete walkthrough of how to go from a simple chatbot to a powerful tool-using AI assistant you can actually deploy. So if you're interested in LangChain, GPT-4o, and building real-world AI applications, you're in the right place. Let's dive in.
So once we logged in, you can look at any previous history, chat history, if it is there. So in this case, so we have some chat history available. We also have the authentication mechanism. So a user can log in and log out. All of the session conversation done during a session is stored. So this retail chatbot has three data sources through its giving all the information. One is the information related to the order. So any order that's been done has the information. It can access the database and can fetch the right answer for you. What's the status of the order, where it is right now, and whether it's been delivered or cancelled, etc. The second data set is about the question and answer related to any company policies, any product related thing that you want to ask. And the third is about about the real-time inventory information. So it has all the information about the inventory of a particular item. You can ask different questions. So let's start exploring it. For example, I just want to ask about, do you sell PNV laptop? Yes, we do sell HP laptop, and it's currently available in stock. Let's say I want to ask about its availability in Auckland. Or you can ask question anything related to, for example, what are delivery charges to Auckland. You can ask about, do you offer reseller wholesale pricing to resellers? We can inquire about a particular order. For example, we can log out, log back again, look at the previous conversations. So let's see how RAG or retrieval augmentation generation works. So if I explain it very simply, think of RAG is like giving your chatbot its own internal Google search capability. It first looks up relevant answers, then writes a custom reply based on what it found. And instead of making the LLM guess, RAG gives it the right information to answer more accurately. Of course, a generic LLM trained on a lot of data over the internet might not know about policies implemented in a company or in a business. It might not know internal details. So that where that RAG comes to play. We will look at a very high level. We have a user query, and the users ask a question. For example, do you offer an in-home installations? Now that question goes to the retrieval part of the RAG. Basically, before this retriever thing, when we are actually creating a RAG, we take all of the documents, company policies documents, question and answers, etc., and put it into a vector database. A vector database is simply a database where each of that conversation or text is first converted to numerical vector and then stored. What this numerical vector does, it helps us basically speeding up the matching process when we are finding the similar documents or similar results to a question. So at the query time, the query is also converted to a vector, and then it's looked at into that vector database, for example, FAISS, and from there it finds the relevant text or relevant document. All of that documents, it could be the three nearest matches, top three closest or similar answers, could be more than that. Those are passed to an LLM, and then LLM now have all the context, all the background information plus retrieved results. Knowing the background context, now it can answer in a much better way. So the final answer which the model generates, for example, in this case would be, yes, we offer in-home installation for like $99. We want to reply specific to that particular company. So that's how RAG plays a very important role. Okay, let's get started with the code. First of all of this code is available at my GitHub repo, and you can find the link in the description. First, look at the data we have. We have 3 different files. This particular file contains information about support questions or queries that a customer can ask from the chatbot. This is not a real data. This is generated using generative AI, and it's not perfect. There are problems in it. So this data is divided, you can see, into different groups, like technical specifications related questions, warranty related questions, or it's about like return and refund policy, etc. As this is generated using AI, and so there the questions are sort of repeated, and there are some instances where the same question is repeated multiple times, but they've got different answer. In this case, it looks like they've got exactly the same answer, but there could be a scenario where the question is the same, but they've got different answer. Yeah, here you can see here, maybe it's talking about the resolution. So that's not perfect. There are problems with it, and that data needs to be fixed and improved. So the purpose is to progress, create a video where you can see the progression, how things are improved, things like how the prompts are improved, how the RAG is improved, how a better LLM is improved, and how the overall architecture of the project is improved. If you look at the other data, so this is about the inventory or the stock information about different products and their availability in a particular city, and the number as well, like how many or the quantity is available. The third one is about orders. So you can see a particular order and the customer email, and we also have the product being ordered, the quantity, the date ordered, and the delivery date, and the current status, and what was the destination. So all of these data have a bunch of problems. I'm not going to improve or fix those, but we'll be doing that definitely in a later on tutorial. So let's jump back to the code again. So we have a bunch of imports, as I already mentioned. So first and the foremost is loading our API key. As I mentioned, we'll be using OpenAI services. So I already have that key set in this environment file here. Using this, we are loading that key, and it's been now set into our project environment. And next is loading our data set. So loading these 2 files. As you can see here, we are loading things differently. So what I want to do really is that this file, the realistic retail support questions, and this inventory status, I want to keep those in a RAG application, which means user can ask questions related to it. I want an LLM to answer it. And here I want to take help of I want to keep it as it is, like it's a database. It's not considered as a text file or stuff. And I'll be using a different approach to retrieve data from this file, because I want exactly the same information here, because if this particular order is given, I want to know the exact status of it. Here we have the option that in some cases, for example, if I just ask question that, do you have Logitech MX mouse, without specifying the entire detail, I still want to provide that, yeah, we just have this particular mouse and we have that many instances available. So you can see, look at the code here. So I'm retrieving this data into through 2 different ways. This particular data set, the question and answer one, and you can see it's been the question and answer one and the inventory one, they have been loaded as CSV files, while these one is loaded into a pandas data frame, because I want to run query on it in a different way. Now, one of the things that we do immediately after the data is that we just don't feed it directly to a RAG or whatever thing we're using for storing the data. We just split it into different parts. If that would be a unstructured document, like some document containing lots of paragraph, then we will use a different approach to split it. We might go with things like splitting up based on number of tokens or number of words. Let's say we can say that split the document after every 500 words if it's a longer document. In this particular case, because our document has sort of separate lines, it's a line by line information, I don't want to mix them to each other. So I'm using a sort of line splitter, and where we can configure by saying that after how many lines we can just create a new chunk. So on these 2 documents, the support doc and the inventory doc, I'm applying this line splitter. So this here we have all the chunks available, and here I'm saying that they're split after every 10 lines. So in this tutorial, we are keeping things very simple. We're not adding any complex string, trying to just clear up the concepts and see how the things are really working. And after we have all the data been split into chunks, we want to store those chunks into a vector storage. Now, what a vector storage does that it converts all of these chunks into some numerical numbers of a particular dimension. It could be like 500 dimensional vector. It could be larger or smaller than that, depending on the embedding technique we are using. And that embedding or that vectors of numbers is then stored in this vector storage rather than storing the actual text information. It helps quick retrieval of, or it helps in the searching of these vectors later on. So to convert these into numbers, we are using an embedding. In this particular case, we are downloading that embedding from HuggingFace Embedding. We are using this particular one. And then we want to just store that to our local vector storage. So this is an open source dataset from Facebook. We are storing these chunks using this embedding into this support, this database, and then we need to configure a retriever on it. So the retriever will be helping out in retrieving the information, in getting us the results when we have a query. So all of these components go to a chain. We'll be using an LLM from OpenAI. As I was saying, that an embedding model like we are using here, HuggingFace Embedding, or we could have used an OpenAI embedding or from another provider. So it converts text into high dimensional vectors, and the LangChain currently it creates a FAISS vector store from our documents. So as I mentioned, we are using this particular one. Now here we are creating a retrieval. Now a retriever converts FAISS vector database into a retriever object. Basically, we are creating sort of a mini search engine to look into this data set and fetch the answer. Now the next line basically combines everything. It creates a pipeline, usually which we call the RAG pipeline, where we have our retriever and which is going to help us sort of compare and fetch us the answer. Now we want to do similar thing for our separate data set. Basically, we are creating two different RAGs here. We are not mixing them up. They could have been added to one RAG along with many other extra data as well, but currently we are just separating them out, trying to keep things as simple as possible. So we have this function for our order data set. We want to work is like it's a traditional data set. So we are using sort of SQL queries in it to look into our particular order and get the exact information from this file. To our agent, we want to give it some tools that it can use for answering the question. So we have created 3 tools. So these 2 tools, again, they are using port chain and our inventory chain, the 2 RAG pipelines. And this one will be using this function to fetch data from CSV file, you can say, or it's more like a tabular format data. Now we want to give all of the information to our agent, and to do that, this is our agent, and it can use these tools that we created, and it will be currently using zero-shot React-based method. Now the React is basically reasoning plus action. In the zero shot, what we are doing that we're not giving any examples for our model, LLM model to use. We're just saying that let's figure it out on the fly. So the way it works that, for example, we have a question, the model will say that I need to calculate something. I can use the calculator tool and I can get the results and I can use it as a final answer. So there's no example given to tell the model to behave in a certain way. Now our agent is ready and we want to basically just use it as a chatbot and see how it's working. So we have our main code. So within this function, it's calling that agent. And as we already know that the agent is using a bunch of different tools to answer these queries. So let's run this file. I would recommend doing all of these imports I mentioned or installing these packages in a new environment, in a new Python environment. I've already created mine. You can look at it, how can create it, how you can activate the environment. But now let's try to run that. Take some time initially. First time it downloads the embedding from the internet. So yeah, so our chatbot is running, as you can see here. Now let's pick some of the question and ask from it. Let's go first from this retail. Let's look at the order one. Let's say, so this particular order, it's called Logitech MX keys and it's been canceled. Copy that order number and say, what is the status of my order? Now, in this particular case, we will be using this function to locate into our data set and answer the question. Yeah, so it's saying the status of the order is cancelled and it's shipping to Hamilton. No support or inventory information is available. Okay, now basically it extracted, as I mentioned, it's the order was cancelled, so that's showing the right status. Now let's pick something where the order has been delivered. Or I can just type in just 5.1 is delivered and shipping to Wellington. You can see it's missing some information here. It's not telling about what was the product, and it's currently saying it is shipping already. It's been already shipped. So we'll be fixing that part. Let's look at the behavior of other parts for now. For example, for this inventory one, if I ask about, do you have this particular mouse available in Auckland? Let's see what it does. Yeah, so there are 43 Logitech instant mouse available in Auckland. So if I just say that, let's say Logitech MX mouse, let's see whether it picks up that. In the other case, in the where I'm using a SQLite query to look into this data set, it would definitely not match that because it's a simple text comparison. Here, because we are using embedding, it should match and show us. Well, let's sort of partially answered correctly. It's available in Auckland. Let's say if there's something which is not available, let's say this one. So this is not available in Wellington. Let's check that. Out of stock. So you can see here, it sort of converted this no information and this number of quantity available information to this wording. So that's the part of the LLM doing. The other information, the availability and numbers and the quantity, all of that has been taken from this file. So let's check one more. Let's say, do you have X1 carbon? Do you sell X1 carbon in Dunedin? It's available in Dunedin. So that's pretty good. Now look into the third data set. So that's the delivery one and that's the other one. Let's ask about, I want to become a seller. How can I register? You need to complete the whole registration form. So here we say that you should contact on this thing, but as I was saying, some of the questions are not correct. The answers can be mixed up. For example, here it say, so you need to complete the whole. So probably it's showing that of the output. That's not problem of the RAG. It's problem of our data because it shouldn't say conflicting things. Here it says we offer discount price on the school and resellers. Yeah, the question doesn't ask about it. So that's my bad. That's problem on my end. Basically, if this data is fixed, then it shouldn't do this like this. For example, now let's try a different question. Okay, what's the warranty on? 1 year warranty. So here it says, yes, we can repair it. Definitely this data needs to be fixed. Otherwise, so it must be one of the answers. So let's say have this question been repeated here, and here it's 1 year warranty. So yeah, exactly. It's but it definitely needs improvement. I'll be shortly doing it and basically adding that to the tutorial. Okay, so what I did, I've updated this file. So we were talking about this file that there are some issues, especially there are repeated questions and they've got different answers. So the original file was like around 200 rows in it. I've updated it and now I've filtered it. Now this is like now 50 rows, around 50 rows, but I've gone to each question and basically tried to keep it as real as possible. There are still, I don't think so there are any repeated questions. If there are, their answers still make sense. They contain the right information. So this is pretty much a more realistic version of it. Now we can look at the performance now. It's already running. Let's say we want to ask about, so here it's interesting because let's say their installation information and for MacBook Air and for different appliances or different equipment. Let's ask about question about MacBook Air. So it's available in major cities across New Zealand. So if we see the output from here, so it's replying one of these. So yeah, it's still some repetition is there, but on majority, it's now a much better version of it. I can get rid of this one, so next time it shouldn't be a problem. And So this answer was right. If we go to another example, let's say for this one, processor, the MacBook Air, the information, the output could be wrong. It's not exactly the specs for MacBook Air, but we just want to see that it should be showing what's written there. It's in an Intel i7. So yeah, but it's the partial information. It doesn't say the entire thing. Let's see what does it say. Maybe it's not outputting the complete length of information. So let's say if I want to ask this question, what's your retention policy for opened items? Before it, as long as they're original, but there may be restocking fees. That's pretty much exactly everything been mentioned. And let's ask this question about offer bulk pricing to resellers. It's available for school and resell. Yeah, this is exactly what I was expecting. Let's check this as well. Yeah, so as compared to others, while other equipment I mentioned 1 year manufacturer warranty, here I mentioned 6 months, giving the right answer. I'm pretty much happy with this output. Now let's look at the other one. Yeah, the second thing I want to improve is the way it's mentioning it's giving the order information. For example, when the order is cancelled, it shouldn't say that the order is shipping to Auckland. It's been cancelled now. It's not shipping anymore. So I'll be fixing that bit. So for this one, the previous was just fixing in the file. There's no other change in the code. For this one, I'll be making some changes in the code and we'll be doing it together. So let's ask this question. What is the status for my order? This currently processing, and the ASUS ROG gaming is available in inventory. So let's look at the inventory one. Right, maybe it's using both of that because the ASUS ROG been mentioned here. Let's pick something which is only in this data set. Yeah, I'm sure about this Samsung curved monitor. In fact, this laser printer, I know I don't have any question regarding that. What is the status of my order? I want the agent to only use information that's mentioned here, like it did here. Yeah, which is right, and it shouldn't say it's shipping to Auckland. I think I should just fix that. Let's check on one more example where it's out for delivery or it's already delivered. Yeah, let's look at that. MacBook 14-inch. Let's look at it. Let's just say the order number. What happens? The order is delivered. So yeah, it's been delivered. And if I say that, what is the status of my order? And it's shipping to, it should say it's already delivered. It's not shipping and shipped to, maybe it should say shipped to Hamilton rather than it is and shipping to Hamilton, which is not right because it's already been done. So let's fix those bits. Okay guys, so there is one more thing I would like to mention. So let's say we have this query we want to ask about availability of Raspberry Pi. So it says yeah, Raspberry Pi is available in stock at all locations. And so if we do that, do you have it in Auckland? Now here I'm not mentioning about Raspberry Pi again. Let's see how does it respond. So it doesn't know about any information about it because currently we are not using any memory in this chatbot. Every question is treated as a new question. There is no background linkage with it. So the model, so the chatbot doesn't behave accordingly. What I want to add is add some memory to it. At least for one session, we know about what conversation was happening. And if we ask any such repeated question, the chatbot should be able to answer it. So the way to do it is that I've added this conversation buffer memory. So this sort of takes care about for keeping the memory until a single conversation is happening, like until a single session. There are other kinds of conversation buffer. One other is called like conversation buffer window memory, where you can define how many questions or how many conversations, for how many conversation it should keep the memory. You could specify a number, let's say past 10 conversation or past 20 conversation, something like. Currently I want to use the buffer one where I'm not applying any limit. It's just during this one session it will keep recording all of this. So the way to do it is that we will be adding, so we have added a new memory instance where we're defining that we want to create this memory. Then here within our agent we'll be adding this instance. I think that's it, pretty much that is it. And let's try, let's run that, see how it works. So the goal of adding the memory was that we wanted to have our previous conversation in the history, so it can be used as a context when we ask new question, like I answered about a particular product item, and if I just ask a new question without saying its name, then it should be knowing that which product I'm talking about. So we added conversation buffer memory, and here we can see it, and this memory was again added to our agent. Along with that, there are a bunch of other changes we need to make. Now, the behavior that we wanted to achieve for that, our agent should be of different kind. It should be a conversational React description agent. That's the behavior, how it works, rather than zero shot React description. As I mentioned before, in zero shot, basically each question is treated as individually, but we wanted more like a conversation where previous conversation is also important. So we need to make that change here as well. So along with that, there are a bunch of other improvements that I've made it to this code. I would like to go through them one by one. First, I would like also to go through and see the behavior, how is things currently working, and then we'll go to all the changes we made. So let's run this thing. Okay, so let's go to our questions again. Now, one thing I did that you remember our question dataset was something like this, where we had one more column here, and it was called category, where each question had a different category. So what I decided that we really want to use this question, and rather than using any category information, so to make things simpler, I've removed that from here. There is one more thing which I did, and that was some causing problem, was that you can see there are similar questions or exactly the same question, basically with slightly varying answer. That is not a good thing to do because it adds confusion for the model, because you can see here again these three questions. So here is an updated version of that file. Here now each question is repeated once, and for these questions, like where there were three questions, if needed, I've added the content to that single question. So now you can see that the answers are much more lengthier because they contain a lot more information, but I've tried to reduce the repeated questions here. So that was a thing. Another change was that we updated our model. Previously we were using by default GPT 3.5. Now we are using GPT 4.0 model. I would like to add a bit more about the behavior of the agent. So as we were using previously zero shot React description, you can see it can use tool, but it doesn't use memory. That's why we shift from this one to this one. This can use memory, and we can have the behavior of like multi-turn chat with tool use. There is another type as well, chat conversation, which is pretty much similar to that one. Now, one of the important thing I just want to mention about React. Now, the React is basically it provides, or it tells our LLM how to behave. It's a certain way. It tells that you should have a thought and then action pairs. So basically, the model thinks about steps by steps doing something, and then it takes some action. So this is how the React works. So you can also see in the output, we are showing the output, so you'll be able to see how the model is thinking. So on this new line, let's ask our question. Let's say I want to ask about how long do it repair take usually, and you can see. So you can see those thought and action pairs. It's thinking like, do I need to use the tool? Because the first thing is the model have to pick one of the three tools, and then the agent have to pick one of the three tools and then use it to answer or get the data and then answer it. So this particularly, you can see that it's saying that we need to use the support information, which is a particular document. And again, here it's fetched the answer. It's got the observation now, which is like the answer from it. And then finally, it's using all of these data to give this final answer. So it's using the information and saying repairs typically takes 3 to 5 days, depending on the availability of parts. If you have any question, feel free to ask. Similarly, if I ask question about, let's say, any particular, for example, do you deliver to Christchurch? Again, it's using that particular tool, and the final answer is yes, we deliver to Christchurch with next day express option. This is right. And let's ask about a particular product. So you can see it says location 48-hour purchase. That's exactly the information written here. So now this agent is working really nice. And let's say I ask about, can you repair? I say, okay, what if I just say about MacBook? Do you repair? I'm not asking about MacBook Air. I'm just asking about any Mac. So it's sort of deduced from the given information that yeah, they do repair the MacBook. That's sort of more generic thing, and it asked to contact the service center, and it's really working now nice. So what is your refund policy? Similarly, if I ask the same question in different way, do you allow refund? Again, it's here it's picked the correct tool and it's saying yes, we allow refund. See how it's changing the word, the way we ask the question. You can request a refund, returning products. That's the pretty much similar information. Now look at the other data set for the inventory one. Here I want to ask, let's say, do you sell XPS? I'm just saying XPS. I'm not mentioning XPS laptop. Now, it picked it from it's going to the right tool. It's going to the inventory information tool, and then it's answered, yeah, we sell Dell XPS 30. Now, if I say, do you sell XPS 15, like the 15-inch model? I'm sorry, but I don't have any availability of that 15 model. And if I say about, let's say, curved, just ask about the curved monitor. Do you sell curved monitor? See how it's much more, much better as compared to previously, where it was just dependent on those repeating exact words, where if the question is slightly different, then it will give a wrong answer. Like even when I practiced or I was testing, if I just don't say that HDD rather than if I say hard disk, it won't be able to tell that. So you can see here, I didn't use the exact words. I didn't use the HDD word for hard disk. I used saying hard disk, and it sort of knew that I'm talking about a hard disk, and it gave another option that we have this particular option. And when I'm saying, is it available in Auckland, it knows we are talking about that particular hard disk, and it tells about the exact quantity. In fact, this is how many we have in the stock. Let's ask one more question about X1 Carbon. Again, a very small part of the product name, and now it's corrected it that we are talking about Lenovo ThinkPad X1 Carbon, and that's how all of the context information is used. And now our answers are much better. I'm really happy with the way things are. What is the status of this particular order? Let's see. And now it's saying that it's already been delivered, has been delivered. And if you remember previously, I mentioned that it's saying it's currently, or it is shipping. It wasn't using the correct answer, or it wasn't telling it properly. Now with the better LLM model, the answers are much, much better. Let's see how did we make all those changes, which is working. One is the way we are loading the CSV. You can see here, if you look at the actual file, we had one of the column called question. We are using that as a source column here. What it does that it sorts of recognizes that this is the question part in the document, and in our embeddings, the whole line is created as a single embedding. So we are not just creating, at least we could do that, we could only create embedding for the question part, but sometime what happens that the question matches to something which is in the answer. So in that context, creating an embedding for the whole thing, sometimes it helps as well in getting the right answer. So in our case, we are using the complete row. We only have a limited number of rows, just 40 rows left now. We are not splitting any line by line splitting now. We just want to use the whole document because the document is not lengthy at all, and it's perfectly okay to use the whole document as it is. Yeah, one more thing is that you can see in our support chain or the chain created on our support document, we've passed the support doc as it is. The support doc basically contains multiple lines without any splitting been done over it. We've passed that as it is to our for creating the embedding, and we've also added this chain type equal to stuff parameter there. Basically what it does that it's combine the retrieved documents into a single prompt that is passed to the LLM in order to better understand the context. So if you have your documents are not lengthier, then this can work totally okay. It can be problematic when there's too much information in the retrieved document, so you are basically spending all your extra tokens because you're keeping them in the context. We've done the similar thing in the other chain. The most important bit I would say is the way we updated our tools. If you see, previously we had these single liner explaining the behavior of our tool, that way we want our tool to work. But now we have added it to be much more explanatory. So use this tool to check product availability in the inventory. Input should be product name or natural language query like is it recipe. So these are the given. I've given a bunch of different examples from our document. We've done similar things with other tools as well. So for example, for this tool, we have added this thing. Input should be natural language query like what is the status of the order. So again, providing some examples. We've added this function. Basically, this function, what it does that previously we were using this function to run the run function to run this chain. Now we are using an invoke function. The only difference is that now we are returning a particular parameter which is the result that contains our actual result, rather than because this particular model call can return many things. Another important thing is our system message. Now the way system message works is that we have a behavior of a tool and we want to define a behavior of an agent. Now the behavior of the agent sort of supersedes all previous behaviors. So for example, we want to say that here you are a helpful retail assistant which answers sort of these queries, and we've also provided our model how to think, how to reason. So we want our model to think about something, then define the action, and then we want to do that multiple times until we reach to a better answer. So these serve as a guardrail. We are limiting the behavior of our agent. So when it's stuck into a situation where either it's not able to select any tool, it knows exactly what to do. So here it's saying how to provide the final answer. And this is also important. It's saying do not mix formats, do not output both actions and final answer together. If you answer unsure, ask for clarification instead of just guessing. Always be helpful, polite, and clear in your responses. So let's say if I ask question about an order which is not available there, it is not the correct order number. Let's see how the agent is behaving, saying order not found. So the observation is order was not there. So the final answer is it seems that there is an issue with locating your order using the ID. Please double check. So that's a really good reply. So I'm sort of very happy with this tool currently, with this agent, how it's working. I would like to really see maybe a web UI where we can just access the agent and log in, do the authentication, and just play with it. So basically it would require implementing some APIs along with it, and I also want to store the conversation into a database so it remains persistent. So whenever I can log in again, I should be able to see all my previous conversation. Let's start implementing it. Okay, let's start by creating a new file here in this app directory, and we're calling it API file. So what this does that it allows us to call, and it defines an API endpoint which will be called to get the chat responses. So you can see here we have a chat request and we also had a chat response. Basically they both return strings, and this our chat endpoint, it uses this chat request function and then calls our agent, and at the same time, so here after calling the agent it gets the reply from. So that reply is stored into a database. We are creating a database here of chat history database on the fly, and first time if the table is not there, that will be created. For other times the information, the responses will be added. So what we are adding here is that we are adding a user, like the user which logged in, and the question and the answer. All of 3 bits are stored in the database for later on retrieval. So that's basically the purpose of this API file. So yeah, so what we've been trying to do is that we want to see a web app where we log in, and after a certification mechanism, and we should be chat, all of that what we'll be doing here, chat window, term chat, prop chatbot mechanism, and we should be able to chat tree. So in order to do all of that, basically we need 2 main components that needs to be added. One, we need a web component or a web app. We'll be building that web app in Streamlit, and then we need API in order to communicate, fetch the data to communicate with this our chatbot. We need APIs for the purpose, so we'll be building that using FAST API. And let me show you the demo what we have right now. So yeah, basically we want something like this. We have the user information. This is actually the working code, the final thing. So we have a user, let's say Sarah, username, password, login. So I've been doing some chat in the past, so let's see, we can load that chat from chat tree, couple of questions, and we can ask all of those things that question we ask. Say check about order, it says order cancelled, and what's intended to be shipped to client. So all of that things here, we can log out and log in back in using the same user. So all of the chat functionality is as it is. I didn't do any upgrade to that. Now let's see how to build that component, what we have, like the web part and the API. Now let's look at how things are working. So if we see overall, let's look at the flow, how the information is happening. As I showed you that particular web UI. So from that user interface, currently because the app is not running, that's why it's causing problem. But this user interface, which is created in Streamlit, that's the interface to the chat. And then we have our API, which handles the requests and saves the history. And then we also have the chat engine, which we already saw the working of it. And in order to run this app, we have a fast API server. Now let's look at each of that component, and let's look at a very high level how it's working. So this run API file. So this is our fast API app. As you can see, it imports the router from api.py. The router been defined here, and you can see at the top here. So it imports that, and it launches the server via UVI cord. So the way to run this app is that you type in this command, UVI run API app, and reload. So this basically runs this fast API server. And if we look at the next file, our API file, this basically defines the chat logic API. It contains, so here is our endpoint for the chat, and it handles requests from Streamlit or any other front end. So, this API can be called from any other interface as well. And it also calls our agent. So you can see here, it's calling the agent, which is defined in the chat engine.py, and it logs all the responses and the messages to the chat history. So it's storing the user and the question of the user asks or queries and the results. All of that's been stored here, and that function basically logs all that information. So what this function is doing is creating a new database, and it's creating a new table within that, and here it's inserting all of that information in there. Now let's look at our third file, which contains majority of the things. So this is our you can say our front end and our user interface. So when we press on the submit button, it sends the user query to fast API server using requests.post, and it receives the response as we saw that and show it on the chat interface. So that's essentially what it is doing. Optionally, we can see that it can load the previous chat history already been saved. Now I've added bunch of extra stuff for authentication mechanism. Ideally this should not be part of this, but just for completeness I've put it here. So basically I've defined 2 users, John and Sarah, and this is their passwords. And this is like a small database where we have this mapping between the username and the password. Now the password has been hashed, so whatever we type in the chat interface, it is hashed, and then it is matched with the information provided here. And this helps our users to stay authenticated, and when we are logging all the chat history, it's using that user interface. So the most of the code here is just different criteria to say whether it's authenticated or not, what happened when it is authenticated, and if it is not authenticated, then it should be logged out, things like that. All of that logic is there. And so yeah, so this is this particular is the part where we are retrieving the saved chat history So if you look at the flow again, so the flow is that from this user interface, user types a question, the Streamlit app is behind it, it sends API requests, and the API basically calls our agent, and it starts an agent. The agents are defined in our chat engine, which has all the capabilities of storing the context, storing the memory, reading the documents. All of that logic is in there, and then it saves it and finally displays it back.
Thanks for sticking with me through this build. I hope this tutorial gave you a clear, hands-on understanding of how to create an intelligent, memory-aware retail chatbot using modern LLM tooling. I work as a contractor and also run Data Dojo Solutions, where we help businesses build real-world AI products like this one. If you found this helpful, consider liking the video, subscribing for more AI tutorials, and feel free to drop a comment or question below. See you in the next one. If you found this tutorial helpful, feel free to give it a like and subscribe. I'll be sharing more practical AI and LangChain projects soon. And if you're working on something and need help building an AI chatbot or assistant, my company, Data Dojo Solutions, offers AI development and consulting, so don't hesitate to reach out. Let me know in the comments what you'd like to see next.